So hello, my name's Stuart Harrad, along with my co-authors Daniel Drage and Mohammed Abdallah from the University of Birmingham, and Nina Wemkin and Marie Coggins from NUI Galway. I'm going to talk a little bit about the Elevate project that was funded by the EPA. Just some background about Elevate. What we did was we measured concentrations of persistent organic pollutants. Those are brominated flame retardants, BFRs, and perfluoroalkyl substances, PFASs. And most of the substances are very widely used in everyday goods, such as furniture and like electronics in the home, for example. And we measured them in samples of indoor air, indoor dust, drinking water, and human milk, so breast milk in Ireland. Now these POPs, these persistent organic pollutants, are of toxicological concern. We're concerned about adverse health effects on humans, and bans and restrictions, most notably listing under the United Nations Stockholm Convention on POPs, have been introduced over the last 10 to 15 years or so to remove them from the environment. And also some human exposure limits have been set for some. So I'm going to talk about two highlights of the Elevate project. The first one is revealing the impact of these measures that were taken, like listing under the Stockholm Convention, to reduce human exposure to POPs. And so we measured brominated flame retardant concentrations in human milk collected in 2016 to 2018 and compared those with measurements made for the same chemicals in samples that were collected in 2010 and that have been reported previously. Now, our results show a significant decline for those chemicals, those BFRs, where action was taken earlier, so in the middle of the first decade of this century. And most notably, there we can look at some of these PBDs, polybrominated diphenyl ethers. There's one there, BD47. You can see on the left there, the red figure, that's in 2010, and you can see the range of the concentrations in 2018, the Elevate project. You can see the lower concentrations. The same for a similar chemical that was restricted also in about 2004. We can see a big drop in concentrations. One that was restricted more recently, so only in the last decade or so, HBCDD, hexabromоcyclododecane, was still seeing an encouraging downward trend. However, for chemicals such as DecaBDE, this one on the far right, BD209, the impacts of those restricted, these were restricted later in, say, 2017. They were listed under the Stockholm Convention. We're not seeing that decline coming through yet. Also, we evaluated compliance with exposure guidelines for perfluoroalkyl substances. And the European Food Safety Authority recently announced a new tolerable weekly intake for some of these. That's only 4.4 nanograms per kilogram of body weight per week. There's a URL you can click through later there when the slides come through. What we did was that we measured exposure for what people are exposed to via indoor air, dust and drinking water. So this is the non-dietary exposure you can see on this graph. And at the bottom there in green, you can see this tolerable weekly intake for EFSA. And then we saw that the most highly exposed children were actually exposed above this, just down to non-dietary exposure. But for adults and most children, we weren't seeing an exceedance of this limit. We also did some pharmacokinetic modelling comparing external and internal exposures from Elevate, and this suggests though that dietary exposure will add significantly onto this non-dietary exposure. So in conclusion, I think Elevate highlights the crucial role of exposure science in environmental protection. Thank you very much. Happy to take any questions.